99.99% the collision what we come across in our daily day-to-day life is only inelastic collision. That means energy is lost. Energy, there are so many forms of energy: mechanical energy, heat energy, light energy, sound energy, nuclear energy, electrical energy, and so on. Here we are going to restrict our discussion only with mechanical energy alone. So mechanical energy, two types: potential energy, kinetic energy. Energy possessed by the body by virtue of its position, you call it as potential energy. Energy possessed by the body by virtue of its motion. When the body is moving, the energy possessed, that is called the kinetic energy. Sir, energy is nothing but work done, force into displacement. Suppose this is ground level, you are raising a body to a height h. The body mass is m, then the weight of the body is mg, acting downwards, gravitational force. Therefore, W is nothing but potential energy, UP, U suffix P. Force into displacement. You are raising the body to a height. So theta is equal to 0. Theta is equal to 0 means Fs cos 0. Okay. So Fs. What is the formula? Force into displacement. The force here is nothing but the weight of the body, ma. And the displacement is here is nothing but h. So the potential energy for a body which is raised to a height is mgh. Every one of you knows this formula. Potential energy expression mgh. But unfortunately, most of the students, anywhere when the teacher is asking a question, what is potential energy, what is the expression, means immediately they will tell mgh. mgh is not always true. You should remember only the work done, because elastic potential energy is there, electric potential energy is there, gravitational potential energy is there. Formula will change. This is a potential energy for a body raised to a height. You have to remember the work done formula only, because work done and energy both are same. Capacity of doing work only we call it as energy. Both are same. Unit wise joule, dimensional formula ml square t power minus 2. Whatever you have studied for work, same thing is applicable for energy. Correct? So this is mgh, expression for potential energy. Next, kinetic energy. Again, work done is equal to force into displacement. Force F is equal to ma. What is A? Acceleration. From equation of motion, we can calculate A. How to calculate? 3 equations of motion we have. V is equal to U plus AT. S is equal to UT plus half AT square. V square is equal to U square plus 2AS. Initial velocity of the body is 0. So V square is equal to U square plus 2AS. Here U is 0, initial velocity. Body starting from rest, anywhere if I using the term, initial velocity is 0. So V square is U square, that is 0, plus 2AS. So therefore, A is equal to V square by 2S, implies F is equal to M into V square by 2S. Therefore, work done, that is kinetic energy, UK. What is the formula? Force into displacement. Force here is mv square by 2s into displacement s, cancels half mv square. Half mv square is the expression for kinetic energy. You understand the concept? Good. Next, work energy theorem. Sir, you told work done and energy both are same. Definition wise, when you are doing some work, energy is spent. Or when energy is given, work is said to be done. You know very well there are two conditions for work done. A force must be applied. Because of the force, the body should be displaced. These are the two conditions for work done. Then in the carrying of bucket of water, what I have to do, sir? Take the bucket of water, throw it. Physics wise, you have done some work. Physics wise, work is done. Sir, water will be wasted, a bucket will be broken. That are not necessary. Force is given. Because of the force, the body is moving. Correct? Or displaced, whatever it is. Work energy theorem. Same formula, work done is equal to force into displacement. Force F is equal to ma. Here, acceleration we have to calculate. There is no question of initial velocity is 0. General expression you take from equation of motion. What is that? V square is equal to U square plus 2AS. 2AS is equal to V square minus U square. A is equal to V square minus U square by 2S. Substitute this V square minus U square by 2S here. Implies F is equal to M into, what is A? V square minus U square by 2S. Therefore, work done is Fs. That is M by 2S. You take it out. V square minus U square into S. S cancels. So half M V square minus half M U square. Half M V square is final kinetic energy. Half M U square is initial kinetic energy. So change in kinetic energy is nothing but work done. So this is work energy theory. They are very simple topics. Basic information. Okay. Fine. Next. We are going to talk about collisions. Just introduction. In detail in part 2 we will do. There are two types of collision. Elastic collision, inelastic collision. What is called elastic collision, sir? Collision is perfectly elastic. The meaning, after collision, energy is not lost. 99.99% The collision what we come across in our daily day-to-day life is only inelastic collision. That means energy is lost. Collision between two vehicles, person and a vehicle. This is all macroscopic collision. Macroscopic, the meaning, the mass of the body is involved in this is extraordinarily high. So that and all will come only in inelastic collision. Elastic collision means collision between subatomic particles. What are subatomic particles? Protons, electrons, neutrons. Between two electrons, between two protons, one electron, one proton, that collision, if it is happening, it is called elastic collision. Correct, Amma? Simple topic. Example for elastic collision, example for all collisions are inelastic only. Here, one or two examples. Energy should not be lost after collision. That is called elastic. We have a derivation for velocity of the body after collision. Okay, that we'll deal in part 2. Work for energy. Second part we will discuss. Okay. Law of conservation of energy. Law of conservation of energy. Everybody will tell the definition. Newton's third law, everybody will tell. For every action, there is an equal and opposite reaction. Like that law of conservation of energy, every student will tell. Energy can neither be created nor be destroyed, but it can be transformed from one form to another. You cannot create an energy. Energy possessed by the body cannot be destroyed, but it can only be converted. Of course, there will be some energy loss. Between collision between two macroscopic body, energy loss will be there. Okay. So that we are not going to talk here. Law of conservation. Energy is conserved. Energy is constant. That alone we are going to talk. Sir, 3 points I am considering. Point A, point B, point C. A and B raised to a height h. C is at a depth of x from the top. Total energy at A. 3 places at the point A, at the point B, at the point C. What is the energy? Sir, at the point A, that is the lowest point, potential energy is 0. Why? There is no height at all. Potential energy is 0. mgh, h is not there, so 0. Kinetic energy is maximum, ek. So this is called the mean position, equilibrium position. Sir, please tell one more example. We can tell. Simple pendulum, you are oscillating. When pendulum is oscillating, when it goes to the extreme end, it comes to rest, then comes back. So extreme end, the velocity is 0. Velocity is 0 means kinetic energy is 0 at the extreme end. Potential energy is maximum. Same case. So at the equilibrium position, so when it crosses to the center point, velocity is maximum. So only it is moving to the other side. Center point means the rest point, equilibrium point. There is no potential energy there. So potential energy is 0 at the center. Kinetic energy is maximum. Same case here. So at the mean position, potential energy is 0, kinetic energy is maximum. So total energy is fully kinetic. Here, total energy at B. Simple. Potential energy is maximum. Kinetic energy is zero because you are projecting a body. When you project a body, you are putting a stone upwards. Velocity goes on decreasing. At the highest point, velocity is zero, so it is coming down. So you can say kinetic energy is zero at the extreme position. Potential energy is maximum. So at the highest point, you have whole energy is due to potential energy only. Next, total energy at sea. Sir, here at a depth, so potential energy is mg h minus x. How much height it is raised, ma? H, this x you subtract h minus x plus half m v dash square. So it is partly kinetic and partly potential. Correct? So it is not fully kinetic or fully potential. It is partly kinetic and partly potential. Okay? If you substitute these values, we can prove the energy is constant. Equation wise also we can prove energy is constant. That we are not discussing here. Graph also you can draw. This is mean position, equilibrium position, displacement. 3 points we will take. Join these three. These 3 points you take. Join these three. What is the meaning, sir? What you are drawing? It is between energy and display. This is displacement. This is energy. Sir, energy is maximum at the equilibrium position. Maximum at the equilibrium center. Extreme position, energy is zero. So this should be kinetic energy, EK. Mean position, potential energy is zero. So this is EP. Extreme position, it is maximum. In between means you can take this point I want means what is the potential energy, what is the kinetic energy. This point I want, sir. Accordingly, what is the potential energy, what is the kinetic energy. Correct. So this is law of conservation of energy. Graphical representation. So to sum up this chapter, work power energy. Work done means it is the scalar product of two vectors f dot s. That is f vector dot s vector. Fs cos theta. Theta is equal to 0, theta is equal to 90, theta is equal to 180, we can discuss. Theta is equal to 0 means work done is maximum. W is equal to Fs. Then work done by constant force, work done by variable force. Then we saw power. Power is nothing but rate of doing work, work done by time. Another formula for power. Actually, the power formula is W by T. When you substitute the value for W, we can get final answer for power as P is equal to F dot V, scalar product of two vectors. F vector dot V vector is equal to power. Unit of power is watt. Horsepower also we can use. So some cases, SI unit is watt only, joules per second or watt. 1 horsepower is 746 watts. Energy, capacity of doing work, we call it as energy. Mechanical energy, we have two types. Potential energy expression mgh. Kinetic energy expression half mv square. Then we saw the important concept, work energy principle or work energy theorem, relation between work and energy. And we have proved work done is change in kinetic energy. Correct? Then law of conservation of energy, we saw definition. Then collisions, two types of collision we have, elastic and inelastic energy. Okay, this is the sum up of work power energy topic. Very interesting, very easy chapter. Okay, thank you. We'll continue. If you want only English lecture, for better clarity, I would have used one or two places Tamil version. Only English lecture. Please watch my videos. You will get the link. Okay. Thank you. We'll continue.